Hi, in this video, we're going to talk about exponential and logarithmic equations. So these equations that we are going to deal with involves exponential and logarithmic expressions. Remember, um, equations that involve terms of the form b raised to x, where remember b is greater than 0 but not equal to 1, are often referred to as exponential equations. Such equations sometimes be solved by applying the laws of exponents. So remember the laws of exponents. And this following fact, which is this one, property 7.1. If we have this one, if b raised to u is equal to b raised to v, take note that the base are equal, then automatically we can say that the exponents are also equal. So let's apply this idea together with some laws of exponents in order to solve the so-called exponential equation. So we have examples here. Let's try letter A. So for letter A, we have 2 raised to 2x plus 1 is equal to 4. So as you can notice, the exponent is an expression. Now, how do we find the value of x for this equation? Now, to do that, make sure that the left and right sides do have the same base. So in the right side we have 2, and on the left side we have 2, on the right side we have 4. Before we can apply this idea, make sure that the base will be the same. So we have to find ways that this one and this one, this expression and this, should have the same base. Now it's easy to recognize that 4 is equal to 2 raised to 2, and for the other side, just simply copy. So that's 2 raised to 2x plus 1. So now, as you can see, they have the same base already. Okay? So since they have the same base, so we are ready to apply 7.1. So now it says here, if they have the same base, then automatically they have the same exponent. So here, they have the same base, therefore this one and this one are equal. So we can get x by applying that property. So 2x plus 1 is equal to 2. Okay? So this one and this one are just equal. And get the value of x by using the properties of equation. So yeah, so that's minus 1, and then you have 2x equals 1. Therefore we have divide 2 both sides so that we can get the x. So of course x is 1/2. So that is our value of x. So this is the value of x. Now let's try to check whether our answer is correct. So of course we let x be equal to our initial answer, that's 1/2. Just simply substitute in the original equation. So this is the original equation, as you can see. Okay, and of course just simply substitute. So 2 raised to 2, our x here is 1/2 plus 1 is equal to 4. Simplify the exponents, so you have to cancel this out, so we're left with 1 plus 1, so that's 2. Of course yeah, so of course this is obvious. 2 raised to 2 is 4, which is equal to 4. So meaning our answer for x, which is 1/2, is correct. So we're done. So indeed our answer is x equals 1/2. The value of x is 1/2. Similarly for number 2, it's quite easy because as you can notice, the base is already equal, so just simply equate the exponents. So we have x equals 5. So for letter B, you have 3 raised to x, that's equal to 3 raised to 5. They have the same base already, applying property 7.1, so automatically x is 5. And so we're done. That's the answer. Okay, for number 3, it's very easy. I'm sorry, that should be letter C. Okay, so you have 3 raised to x plus 4, so that's the exponent, the quantity of x plus 4 equals to 3 raised to 12. So of course they have the same base, applying 7.1, so that's x plus 4, this is equal to 12. So x equals 12 minus 4, so x is 8. And so our answer is 8. Okay, let's check whether our answer is correct. So you have 3. Okay, you're going to let x be equal to 8 and then substitute 8. Let's see what happens. 8 plus 4, that's equal to 3 raised to 12. So of course, 3 raised to 8 plus 4, that's 12, right? So 3 raised to 12. Indeed, they are the same. So meaning the answer is x equals 8. Okay, so I hope you've got the uh, application, how property 7.1 is being applied, as well as, in this case, uh, the givens are quite easy. Okay, so now we are going to consider this equation. So how about when we're going to solve these kinds of equation like this or like this? So as you can notice, the equation is not so easy to solve. When you're going to, sometimes it's impossible for us to quickly get the answer when you're going to apply property 7.1. So in this case, 11, it's obvious that 11, we cannot express this very quickly as having a base of 3. Okay? So it calls for another method for solving such equations. So property 7.1 is not applicable here. So we will consider this property 7.2. So if m is equal to n, remember m and n are positive numbers, then it is automatically that the logarithm of m, which is the left side, is equal to the logarithm of n. So remember that b can be any base. Okay? So it can be 10, it can be whatever base that you want. It can be 5, or it can be e. So there's a possibility that b can also be equal to e. And remember, e is 2.7 and so on and so on. So that's an Euler's constant. So there's a possibility that b is equal to e. In that case, when b is equal to e, so meaning this becomes log e, logarithm of m with base e, and logarithm of e, logarithm of n with base e. So remember that this expression, or this one will become ln of m is equal to ln of n. So, which means to say that it is also legitimate, uh, it is also valid that we are going to use ln, ln, lmn, and lnn. Okay, but ln is also common when you're going to solve equations just like this and this. So here we are going to use b. We're going to use e as our value of b, and therefore we will use ln. Okay, we're going to get the natural logarithm of both sides of the equation, or for this. Okay, so that will be our convention, but you can use base 10. Okay, log m 10 or log n 10, so you can use that, but this time I'm going to use natural logarithm. Okay, but any base will do. Okay, so let's consider the equations above. We have 3 raised to x equals 11. So how do we get the x? So first example, you have 3 raised to x equals 11. So in this case, we cannot apply 7.1. So because it's, we cannot quickly express 11 as a having a base of 3. Okay. So what we'll do here is we are going to apply 7.2 by getting the ln, or the natural logarithm of both sides. So meaning we're going to use b, which is equal to e. So here we're going to get the ln. So this becomes ln x, ln 3 raised to x, and ln 11. Remember the properties that we have learned in our logarithm in our past lecture. So here we're going to apply, remember, we're going to apply some properties like this. So very common. Okay, so let's remember these properties. Okay, remember this property. So this is very common in solving equations involving logarithms. So we will apply this one. Okay, as you can see, this can actually be applied in the left side of our equation. So meaning we are going to bring this down here and become a factor. So now this becomes x ln 3. So x times ln 3 is equal to ln of 11. So we divide both sides by ln 3. ln 3 is actually a real number. Okay, so that's a number already. You can use calculator if you want to really get the value for that. But you can still write that as ln 3. Okay, just leave it as it is. So divide both sides by ln 3 so that we can get the x. Cancel the ln 3. So we are left with x. So we have ln 11 over ln 3. So this will be our answer for letter A. So x equals ln 11 over ln 3. Okay, let's try. There are some advantages if we are going to use ln. Okay, so for example, for number 2, we have the second example. We have 5 e raised to x. That's actually equal to, that's not 24. It should be 25. It's a clerical error. should be 25. So that's 25. So before we can use the property, here, make sure that we are only left with this expression, with this uh, with that expression of that form. So in this case, we have to first divide the equation by 5. Okay, then cancel this out, and we are left with e raised to x equals 25 divided by 5, that's 5. So we are left, so the new equation is e raised to x equals 5. Now, to get the x, of course, we're going to apply the property so that we can really get the x. So now we're going to apply ln both sides, ln e raised to x, then ln 5, get the natural logarithm of both sides. So with that, we will use the property, this one. So this becomes x times ln e is equal to ln 5. Remember, we have another property here, if you can still remember. ln e is equal to 1. Okay, remember this property from our last lecture? So that's always equal to 1. Because, again, ln is equal to log e with base e. Of course, when you're going to get the log e base e, that's 1, right? So, yeah. So this one becomes 1. So x times 1, that's ln 5. Of course, that's x. That's equal to ln 5. And so we're done. Our x is equal to ln 5. But you can get the value or approximate the value of ln 5 by using your calculator. But this one is enough so that we can have an exact value for x, which is ln 5. Okay. So please stay tuned for the second part of this video. We will discuss the last part of this lecture, which is the logarithmic equations. Although we're dealing with logarithmic equations already, more examples of logarithmic equations. So that would be all for this video. Thank you very much and have a nice day.